Taking a very important topic, that is the cyclotron. And from this cyclotron, the question is asked in the board question paper. This is either of 1 mark or half mark or 1.5 mark, like that. But the question is asked. This is a definite one. So we have to study this very well, as we have to find the answer for the question in the board exam. So now I take the cyclotron. Cyclotron. Cyclotron was invented by E.O. Lawrence in 1930 at Berkeley University. California. USA. He was awarded Nobel Prize in 1939 for his invention. Cyclotron is an accelerator which accelerates heavy positive charged particles. Charged particles like proton, deuteron, alpha particle, lithium ion, sodium ion, etc. This machine does not accelerate the negatively charged particles. So this is only for positively charged particles, which are heavy ones. Now we take the construction. It has two hollow metallic semi-circular this called D's called D's because they are of the shape of the D in the English alphabet. As their shape is like D in English alphabet. In English alphabet. So this is like this one. This is suppose a D. This is another D. This is not hollow one. They are hollow. So this is now suppose D1, this is now your D2. They are having the same radius. This is called the D. D's. The D's D1 and D2 are placed with their diameter parallel to each other. Parallel to each other. ये इनका diameter है. Parallel to each other with a small gap between them. This is a small gap. You are looking that this is not diameter, this is not diameter, then this we are having a small gap between them. This is not center of these D's. This is not center. O. This is not center O. The D's are connected to a AC source, AC voltage source. AC voltage source. A strong magnetic field is applied by means of electromagnetic poles perpendicular to plane of D's. तो मैग्नेटिक फील्ड भी अप्लाई किया जाता है जो कि प्लेन डीज के प्लेन के परपेंडिकुलर होता है. तो आपको इस तरह से मानना है दिस इज नाउ योर डी, दिस इज आवर अनदर डी. सपोज वी आर हैविंग these two D's like this one, and the magnetic field is applied like this. This is which is the perpendicular to the plane of this D's. The D's are arranged in a highly evacuated बॉक्स, यानी इनका जो अरेंजमेंट होता है वो एक बॉक्स के अंदर कर देते हैं जिसमें कि वैक्यूम होता है। So this is to be like this. These are now suppose this is now your D1, this is now D1 and this is D2. The RF field is applied like this. This is now RF field. This is now AC voltage, AC source, AC source. And now then we have this now this is the electromagnet here to be applied. This is now north pole and this is a big one, big one. This is north pole and then this is not south pole. Suppose this is the center, the ion is injected at the center and this the RF field is applied on this disk. So this particle moves. Suppose this is now your D1 and this is now your D2. There is a small gap here. This we are having the deflecting window. This is a light hole in these. So this particle is first goes here, then this, here we make the deflection window. Deflection window, this is now and then it hits the target. So this particle is moving like this in this way. In this way. This is now charge particle Q. Charge particle Q. So this describes the semicircular path inside the D and this absorbs the energy from the applied radio frequency source or this AC source. So this is accelerated by this source while this magnetic field having only action that it rotates the particle in the circular, semicircular path. So this is, all this arrangement is made in a highly vacuum chamber or the box. So now what we have, the particle the positively charged particle to be accelerated is injected at, this is now point O, at point O in between the gap of D's. The radio frequency the AC voltage source. This is now like this. This is now 0. This we have now this V. This we have the time t. Then this is like this one. This is now time t by 2. This is now time t, then this is now your 3t by 2. This is now your suppose 2t. So this is the variable voltage. The applied magnetic field. Rotates the charged particle in semicircular path inside the D's. So now let's at time t D1 is at negative potential and D2 is at positive potential. The positive charge is attracted towards the charged particle. Moves in the gap towards D1 due to attraction. तो क्या होता है कि जैसे ये पार्टिकल इधर की तरफ मूव करता है इस गैप में, तो ये इस डिस्क पर नेगेटिव पोटेंशियल होने की वजह से इसके अट्रैक्ट होता है, तो इट मींस दैट दिस इज एक्सेलरेटेड, द पार्टिकल इज एक्सेलरेटेड. And particle accelerated. जैसे ये पार्टिकल इस डिस्क के अंदर एंटर करता है तो मैग्नेटिक फील्ड इज स्विच्ड ऑन. As the particle enters D1, it moves in semicircular path due to magnetic field. तो क्या है कि जैसे ही इसके अंदर एंटर करता है तो यहाँ पर जो मैग्नेटिक फील्ड लगा हुआ है इससे ये सेमीसर्कुलर पाथ के अंदर एंटर करता है, तो जैसे ही सेमीसर्कुलर पाथ को पूरा करता है ठीक उसी समय इनकी पोलैरिटी चेंज हो जाती है D1 एंड D2 की. यानी पहले D1 नेगेटिव था और D2 पॉजिटिव था, अब ये उल्टा हो जाएगा, D1 पॉजिटिव हो जाएगा और D2 नेगेटिव हो जाएगा. दिस विल बी अगेन एक्सेलरेटेड बिटवीन द गैप. As the particle enters D1, it moves in semicircular path due to magnetic field. At time t plus at this time the polarity of these changes, so particle is accelerated in the gap and enters D2 where it moves in semicircular path of increased radius. रेडियस। तो जैसे जितनी रेडियस इसकी पहले D1 में थी अब उससे ज़्यादा रेडियस D2 में होगी इसकी। अब फिर इसमें वही होगा कि जैसे ये D2 में सेमी सर्कुलर पाथ कंप्लीट करेगा, ठीक, फिर इन D1 और D2 की जो पोलैरिटी होगी चेंज हो जाएगी। देन पार्टिकल विल बी एक्सेलरेटेड बिटवीन द गैप एंड देन इट विल मूव इन द सेमी सर्कुलर पाथ इनसाइड द D. So this process is repeated again and again. Thus, every time the particle in these moves in semicircular path of increasing radius, and is accelerated between the gap between the D's by AC voltage. तो एनर्जी तो इसको एसी सोर्स से मिलती है, वहां से एक्सेलरेट होता है। मैग्नेटिक फील्ड का काम तो सिर्फ इतना है कि ये इसको सेमी सर्कुलर पाथ के अंदर घुमा दे। अन्यथा क्या होगा, सेमी सर्कुलर पाथ में नहीं घुमाएगा तो जैसे ही पार्टिकल ये इस गैप से इधर D1 की तरफ जाएगा तो सीधा ये हिट करेगा। तो इसको रोटेट करने के लिए, इसको सेमी सर्कुलर पाथ में घुमाने के लिए ही इस पर मैग्नेटिक फील्ड अप्लाई किया जाता है। तो इसको एनर्जी जो होती है वो मैग्नेटिक फील्ड से नहीं मिलती है, इसको एनर्जी केवल अप्लाइड एसी फील्ड, एसी वोल्टेज सोर्स से ही इसको गेन होती है। सो दिस इज व्हाट आई हैव रिटन हियर। Thus every time the particle in D moves in the semicircular path of increasing radius and this is accelerated between the D's by AC source. When the radius of semicircular path becomes equal to the radius of D's, it is deflected by deflecting plate and particle comes out of D's and finally strike the target. तो मैंने आपको फिगर में दिखाया था कि डीज के अंदर एक प्लेट इस तरह से लगाई गई है, वो डिफ्लेक्टिंग प्लेट होती है। तो उस प्लेट पर क्या नेगेटिव चार्ज, नेगेटिव पोटेंशियल लगाते हैं। जैसे नेगेटिव पोटेंशियल लगाएंगे तो उससे ये अट्रैक्ट होता है। तो बिकॉज द पार्टिकल इज having a very high energy, so this is not going towards the plate, but it is slightly deflected and goes out of the D and strike the target. So this is how the positive charge particle is accelerated by means of the cyclotron. So this machine is very good one for the heavy charge particle to accelerate them to a high energy, and by having the D's of very large radius we can have the very high energy particles that can cause so many nuclear reactions. So this is the construction and the working of this cyclotron. Now tomorrow I will tell you the analytical treatment of this one. So you see that in one rotation the particle is accelerated 2 times while this is crossing the gap. So I will tell you about the energy, the limitations of this one, and also the cyclotron frequency, which is generally asked in the board exam. So this is about what the cyclotron, that I told you this only the construction and that the working of this cyclotron. So thank you very much.